I'm going to record this report from IEA. Obviously, they put this out fairly regularly. This one is Energy Efficiency 2023, so International Energy Agency report. Why am I interested in this? While we keep talking about the need for staying on target for emissions out to 2100 for global warming targets and the necessity of doing lots of electrification, transportation, EVs, renewable energy, of course, and how quickly we have to get carbon capture to work to meet the goals of net zero and so on. The role of the efficiency is not always appreciated enough. If we use the technologies that exist, whether it's internal combustion engines, washing machines, whatever you can think of, the efficiencies can be improved, and improved efficiencies themselves can seriously make a dent in make a serious dent in the emissions. So in that sense, I wanted to include it just to look at some of the efficiency points that IEA makes. There are lots of chapters. I'm going to just read the executive summary. There are a lot of details on how we can get there, what role the government has to play, and what people can achieve by being, more careful about buying efficient things. It depends on cost as well, right? If somebody is selling you a greener washing machine, but it costs much more than the normal one, then you may go for the normal one based on either your income limitations or your ideas about how much you want to do for climate or environment, right? So it's a complicated thing. The abstract is that Energy Efficiency 2023 is the IEA's primary annual analysis. So every year it comes out, and I'm going to do this just as an example. Maybe I'll upgrade every year after this if there are some important points. So the global developments in energy efficiency markets and policy are looked at in these reports. It explores recent trends in energy intensity, how much carbon is being emitted for producing energy, unit of energy, energy demand and efficiency related investment, policy and technology. This 10th edition of the market report also features a new spotlight section focused on key issues facing policymakers this year, that was past year. In particular, the report details what is entailed with the proposed global target to double energy efficiency progress and what will be gained by achieving it. This is important. Where are we headed? Is it an optimistic vision for the future if we focus on efficiency progress? This year's report comes amidst the ongoing effects of the energy and climate crises in what is expected to be the hottest year on record. Did turn out to be so. In this context, 2023 global energy efficiency progress as measured by primary energy intensity. Primary energy is where most of your source is coming from, as opposed to renewables, let's say, or the majority of your energy. This is expected to be slightly below the long-term trend in a slowdown from 2022. However, the report makes clear that a profound transformation is underway in energy efficiency and clean energy more broadly, with many governments introducing new and strengthening existing policies, strengthening existing policies and energy saving programs. So new or strengthening existing policies, and so these policies are leading to faster deployment of efficient technologies and are contributing towards an expected peaking of fossil fuel demand in the coming years. Cross your fingers and hope for the best. But also efficiencies may be increasing, but if people are making choices of driving more or living in bigger houses or living in small nuclear family units, then a lot of the efficiency can be wiped out by increased consumption, like the Jevons paradox that we have discussed elsewhere. Okay, so the executive summary then: efficiency policy momentum builds, but global energy intensity progress slows. Energy efficiency is currently seeing a strong global focus among policymakers in recognition of its important role in enhancing energy security and affordability. and in accelerating clean energy transitions. So you can see that the motivation may come from the country wanting to be energy secure and provide affordable energy for its people, not just the environment and global mitigation goals. This comes, however, as the estimated 2023 rate of progress in energy intensity, the main metric used for energy efficiency of the global economy, is set to fall back to below longer-term trends of to 1.3% from a stronger 2% last year. So energy intensity in this case, I said carbon, but here it is mostly about energy efficiency. So how many units of energy you use to do a certain task. The lower energy intensity improvement rate largely reflects an increase in energy demand of 1.7% in 2023 compared with 1.3% a year ago. Okay, so you can do the calculation how demand and total energy use versus efficiency end up confounding each other. At the same time, this year's slower progress in global energy intensity masks exceptional gains in some countries and regions where strong policy action, increased investments, and consumer behavior changes led to sharp improvements well above the average rate. This year, the European Union and the United States, among many others, since the beginning of the energy crisis, including Korea, Turkey, and United Kingdom, have registered robust improvements ranging from 4% to 14%. Okay, you can go and see what the methodology is used to actually calculate those numbers, but take it as good news, or at least less bad news, because we are still increasing emissions and energy use and energy production from fossil fuels. Renewable energy share is going up, but not fast enough. So here, annual primary energy intensity improvement over 2001 to 2022 and 2023 and by scenarios out to 2022 to 2030. So here steps are stated policy scenarios and APS are announced pledges scenarios, so the NDC kind of thing, and NZE is of course net zero emissions by 2050 scenario. Primary energy intensity improvement has gone up from 2001 to 2010, but 2021 was below the previous decade's average. 2022 jumped up to 2%. Numbers are fairly modest, so make sure you know. So if you want to go to net zero, obviously 2022 to 2030, there is 2 times the improvement over 2022 that is needed. 2023E, which is basically expected at that time of the reporting. These are what you would expect for stated energy policies and announced pledges and net zero emissions. Obviously, net zero will require much higher energy intensity improvements compared to what we've been accomplishing. In 2023, global momentum to target a doubling in the rate of efficiency progress to 4% gathered pace, which could cut today's energy bills in advanced countries by 1/3 and make up 50% of CO2 reductions by 2030. In June, 46 governments participating in the IEA's 8th Annual Global Conference on Energy Efficiency endorsed the Versailles Statement, the crucial decade for energy efficiency. They agreed to strengthen energy efficiency actions in line with the doubling of global energy intensity progress each year this decade. The progress was to be doubled. Okay, so policy action is translating into investment and deployment. Good news again. Energy crisis has unambiguously accelerated the energy transition, with energy efficiency policy action a central plank of government initiatives. Since the start of the energy crisis in early 2022, basically Russian invasion of Ukraine, Putin turning off the gas, and so on, there's been a major escalation in action, with countries representing 70% of global energy demand introducing or significantly strengthening efficiency policy packages. Annual energy efficiency investment is up 45% since 2020, with particularly strong growth in electric vehicles and heat pumps. So some countries, especially European countries, took the crisis as a cue to ramp up their energy saving, energy efficiency, renewable energy deployment opportunities. Almost 1 in every 5 cars sold today is an electric vehicle, and growth in global heat pump sales is now outpacing gas boilers in many markets. Suddenly I have a frog in my throat, but heat pumps, of course, are better than air conditioners for countries where heating and cooling are needed in a year. Doesn't work for the tropics, but nonetheless. So according to IEA's government energy spending tracker, since 2020, almost $700 billion has been spent on energy efficiency investment support, with 70% of this in just 5 countries: the US, Italy, Germany, Norway, and France. Okay, however, the impact of new government policies, regulations, and energy saving programs, coupled with an unprecedented level of investments to scale up more efficient technologies, are not always the impact of these are not always immediate, with efficiency gains and energy intensity progress realized over a period of years. After an energy intensity improvement of 8% in the European Union in 2022, another exceptionally high year is expected in 2023, with a 5% gain in progress. That's expected. United States is also on track to post a 4% improvement in 2023. So figure shows some of it. So we are looking at global energy use coverage of minimum performance standards for major end uses for 2000 to 2023. Here energy consumption covered, so coverage for space cooling, space heating, water heating, refrigeration, lighting, and these are for residential sectors. So 2000, 2010, 2023 expected. So energy consumption covered has gone up. Refrigeration, lighting, wet appliances, displays, space heating, water heating, cooking. So none of them has decreased. Distribution, transformers, and obviously you can see that the 2023 is expected it higher, but if you look more carefully at 2000 versus 2010, you see that wet appliances, you can see what they are. If you can you know what they are. So dishwashers, washing machines, so there is a slight decrease. This one in space heating has decreased, not much change in cooking or water heating, and there is a slight decrease in road transport in terms of 2000 versus 2010, but 2023 expected are much higher anyways. So a strong post-pandemic resurgence in China's economic growth of around 5% is forecast in 2023, along with a similar rebound in energy demand. So that's going to have an impact. What's up next? The deployment of efficient technologies is curbing energy demand and heralding the peak of fossil fuels. This is mostly a hope. So let's see what actually turns out to be the case, let's say by 2030. In the first half of 2023, heat pump sales were up 75%. Is that an indicator of efficient technologies? Yes, but sometimes there are subsidies given for this, and some countries are pushing harder, like the UK versus other countries. So you have to look at the global distribution as well. Global sales of gasoline and diesel cars, 2 and 3 wheelers and trucks peaked in 2017, 2018 and 2019 respectively. That's a good sign there. This means global gasoline demand, which is mainly used for used by passenger cars, is expected to peak and stabilize in 2023 at around 27 million barrels per day. We can look in a few months to see if this materialized. So in addition, the pattern is expected to culminate in road transport as a whole, which includes diesel-fueled vehicles such as trucks and buses, peaking at around 45 million barrels per day in 2025. So peaking of residential gas and gasoline demands here, number of countries versus decline in plateau demand. So lots of countries, reasonable number of countries, and this is for 2007 to 2021. So number of countries here. This is increasing demand, decline or plateau. So increasing demand, number of countries is larger, and countries where a decline or a plateau happened. That's for gas demand residential. This is overall gasoline demand, share of total demand. So decline or plateau demand, number of countries is quite impressive, close to 90 or so. Increasing demand is lower, but there are still some countries where it's increasing. I don't know how much I want to read it, but basically the idea is that countries are focusing on this for whatever reason, energy security and so on. But many countries cannot go along these lines of constantly decreasing energy intensity because they are bound to coal, reliance on external energy sources. They're not energy independent. They don't have sources of gas or gasoline on their territorial lands or oceans and so on. Looking at the major heating countries around the world, residential gas demand has already peaked, plateaued, or is declining in 34 out of 70 out of a total of 78 countries, representing half of all demand. There is also a shift to electrification. So the shift to electrification of transport and heating comes at the same time as renewable energy is taking on a rapidly increasing share of electricity production, which is good news. The world is seeing record hot temperatures and boosting the need for cooling and lowering the need for heating. So you will see those in the numbers we just looked at as well. So data shows extreme heat drives increased demand for air conditioners with sustained average daily temperatures of 30 degrees C, boosting weekly sales by 16% in China, for example. During the May to September global heat wave this year, people were looking online for air conditioners more than ever, with the search terms relative popularity on Google up more than 30% worldwide compared with the historical average level of searches for these months. Okay, so climate change caused by greenhouse gases, warming, more air conditioners. Right now that also means more greenhouse gases till the refrigerants are replaced, and the coolants are replaced, and so on and so forth. Milder winters, the second warmest on record in Europe, also contributed to reduced energy demand, helping improve this year's energy intensity results in Europe and the United States. Doubling efficiency progress could cut energy bills by 1/3 and make up 50% of CO2 reductions by 2030. This would be my main message, saying that efficiency has a lot to contribute with the existing technologies. So just dreaming about scalable carbon capture must go on. Innovations and efforts to scale them up should go on, but in the meantime we should not ignore efficiencies in existing technologies and their applications. As momentum builds around the globe, global target to double efficiency progress from the 2022 level of 2% to 4% each year until 2030, international efforts, including those at COP28, have a major role to play in shaping future energy efficiency and demand pathways. So COP28 is Conference of Parties 28, which is the annual negotiation process that goes on, focuses many things. So in most sectors, governments can make rapid progress towards by building upon best practices in existing policies and accelerating the deployment of already available technologies. So lighting standards, industrial electric motors, and so on, and building regulations, vehicle standards improvements, and so on. Okay, proportion of countries to surpass a 4% annual energy intensity improvement one or more times between 2012 and 2021. So good news there, or less bad news, as I would like to say. Proportion of countries here, almost 90% have exceeded the 4% annual energy intensity improvement. That's not an absolute number, it's an improvement of 4%. They have exceeded at least once in 10 years, at least twice in 10 years, about 75% of the countries, at least 3 times in 10 years is almost 50 some percent, and 4 times in 10 years and 5 times in 10 years. So number of countries that are doing better and better is going up. Compared to a higher energy demand scenario with around 2% annual energy intensity progress each year this decade, doubling to 4% per year would reduce CO2 emissions by 7 gigatons CO2, or 20% of the current total emissions. 20% coming from efficiency improvements. That's not a joke. These benefits only highlight that now is not the time to pause on energy efficiency action, but the time to further exploit efficiency's potential to address the multiple intersecting crises of energy, climate, and cost of living. Finally, doubling progress on energy efficiency. There is international focus on a target to double the average annual rate of global energy efficiency improvements between now and 2030. What does this involve? What is doubling? So global annual progress on energy intensity doubles in this decade, so from 2022 to the period of 2022 to 2030, so that would be 4%. The target is global. All countries have a part to play, and the target will be formally considered at COP28, which passed, I think this year. We are in COP29 in Azerbaijan, but you can check. Why should we double? A critical step on path to net zero, over 7 gigaton CO2 emissions savings by 2030. Today's home energy bills in advanced economies lowered by a third if we double the efficiencies. 4.5 million more jobs than today. Energy savings equivalent to twice the EU's consumption in 2022. So by, we'll save energy, will reduce energy demand significantly. How do we double? Strong policy packages of information, regulations, and incentives, and a tripling of global investments in efficiency lead to the following between now and 2030. Share of electricity in energy demand increases by over a third, and smart grid investments more than doubles. Okay, electrification. In industry, annual energy productivity grows by 2.3% per year, and electricity accounts for 30% of energy use by 2030. Again, electrification. Retrofit rates for buildings more than double to 2.5% per year, saving enough energy to power all the buildings in China and India today. Phenomenal, right? Appliances including ACs and refrigerators require 30 to 40% less energy to do the same job. All markets mainly sell LED lighting, so this is how you would double efficiencies. Cars become 5% more efficient each year, largely through electrification and a switch to smaller vehicles. So increasing efficiency and driving bigger cars is not a good idea. Consumers make active and ongoing behavior changes in everyday life, like limiting heating to 19 to 20 degrees C, or even cooling. Heating cost is much higher than cooling, even though we don't realize it, but basically people tend to put on AC, crank it up, and then wear sweatpants in the house. Sweatshirts and sweatpants. This is not a good idea. Same thing with heating. You don't need to run around with t-shirt and shorts and have very high heating. You could be wearing a comfortable sweater and reduce the heating energy use, and so on. Okay, so sorry to be so brief, but it's an excellent report. You want to go back and look up if you're interested. And again, some aesthetic person will complain that this space between my head and the frame is too large, but please watch without the video. Just watch the PowerPoints, listen to the audio. Okay, see you in the next topic.